Welcome everybody to Hungary, to this very special site, the World Soil of the year 2025 in Hungary, in the middle of the Carpathian Basin, close to Püspökladány, under the nice forest, in a forestry research institute, very close to the Földrajz National Park, which is a UNESCO heritage site. So there are a lot of interesting features around this place. But now the major reason why we are here is this profile, which was proposed as the soil of the year of 2025 and was selected as a winner. So in this year, this profile represents the world soils. And we came here to describe it, to understand its formation, and have a nice short presentation for everybody all around the world just to get it know. But where are we now? As I already mentioned, we are in the middle of the Carpathian Basin in Central Europe. The Carpathian Basin is surrounded with the Carpathians and the Alpines and the Dinarides. And in the middle there is a big plain, an alluvial plain with a lot of alluvial features, a lot of very young formation and geomorphology. Basically all the features that we see around has been developed in the Holocene period. Sometimes the material is a little bit older, but let's go through the entire history. We are now in a very special alluvial area at the border of three different physiographic regions, the Földrajz, the southern Hajdúság and the Sárrét. And all of them are so similar from the point of view of its geomorphology and surface formation. Tectonically, this area is continuously submerging. It means that the elevation would get lower if there would be no new sedimentation. However, as it gets lower, then all the waters, the surface waters around are just approaching the area, attracts a lot of water, and as the water comes, of course, it takes all of its transported material and it sediments the transported materials around. So very young material, very young formation. How does an area look like? If you look at the digital elevation model, what you would see in this area that you see a lot of, let's call it ancient water rivers or riverbeds. And all these riverbeds has a little bit higher, not the beds, but the levee around the beds. It's a little bit higher than the plain itself by elevation. And it is because when the rivers comes, of course, when flood starts and before the floods, the water goes very high speed and has a high transportation capacity, so it takes all the coarse and the fine material as well. But as soon as it leaves the channel and goes two sides to the alluvial plain, then it slows down and immediately sediments the coarser material, and that builds a parallel, higher elevated river bank, basically the so-called the levees on both sides, which is higher than the actual plain elevation, and it has a lot of impact on the classification of the material and on the formation of the different soils, because the area behind the levees we call a back swamp. And that is so different because the water that arrives to the back swamp, it already got rid of the coarser material because it was added to the levee, and now it has only fine particles carried over the area. And of course, when the flood goes away, the flooded water wants to come back to the river bed, but because of the higher elevated levee, it got stuck behind, and it starts flowing back only on a small cuts through the levee. So the water has to stay much longer time, sometimes months, 2 months, or even longer time, and that is much longer than enough to start the clay to be sedimented in this back swamp area. It means that this back swamp is often lower elevated, much closer to the groundwater table, so the hydromorphic impacts are quite likely to happen. And because it has a strong fine material, clayey material covering the surface, infiltration is very slow, so water stagnation is quite common. So stagnant water, as ponding water, occurs on this kind of area and creates a lot of other direction hydromorphology of the area. And we do know that around this area we do have a lot of salt in the water, and as this ponding lake, it's just getting smaller as evaporates and goes back to the original river beds. As it evaporates a lot of extra water, of course the salt content is increasing, and in the lowest part, in the depressions of this back swamp area, at the end it accumulates all the salt and creates salty regions where the salt is from above and not from the groundwater from the bottom. So there are many different kind of salt accumulation processes acting in this kind of area. And the other feature is that what we have to understand, that's gonna be told us by the profile as well, that it is not a stagnant position, but this surface is an ever-changing surface. So what you see now as a back swamp, of course, the water is always changing its position. It cuts itself into its recent or even older floodplains and takes all the previously flooded material and or sedimented material, remix it with its current sedimentation or transported material, and redeposit it in another place, in another composition. And that's gonna create a lot of layerings, a lot of fluvic layers put onto the top of each other, having different physical properties, chemical properties, and different other kind of properties. So it's really continuously reshaping the surface. So that is where we are now. This is a very special place. If you look at the DEM picture, you can see on the first one you will see the overall location, and then we have a zoomed in DEM where you can see the local geomorphological features explaining the genesis of this profile. Actually, let's go down to the profile now, because there are a lot to say about that. It's perfectly shaded now. I don't even know where to start from. But first of all, when you look at it, you see a lot of different colors. It starts with a blackish, dark color surface horizon. And of course, when we are going to zoom in, we will see a lot of other properties, what I will list a little bit later. And then this darker color is getting a little bit lighter, and there is a transitional horizon. And then here we do have a lot of white spots and a lot of brownish iron concretions all around, and blackish manganese one. And then we come further down, we see a little bit more concentrations on these whitish spots, which are the calcium carbonate concretions. And then we have a new layer, a new grayish color section of the profile, which is bordered by two more reddish, brownish reddish border zone. And then we jump to another horizon that comes down to here, where we see a lot of blackish concretions of iron and manganese. The matrix is changing its color to gray, so we do understand that there is a lot of hydromorphology in that. the so-called glaization or gleic property formation. And then we go further down, we see again a totally new material, a nice prismatic structure, fully gray, and the material is, we are going to describe it a little bit later, but the texture is changing dramatically. So the clay content goes to the double. And then under that we do have again a darker color layer, which is of course increasing the organic matter a little bit. This is a buried profile. However, all of this material has been on the surface once in the time, but that was a more stable surface where organic material accumulation and salt formation could take place for a little bit longer time. And then we go down further in where the material is getting a little bit lighter again. The clay content is decreasing. So it's quite a diverse, quite complex soil profile. So let's start from the top first of all. Of course, when we describe a soil, we always have to understand the surrounding, the landscape and the land use. I was explaining the landscape itself, its formation, but we have not spent much time on the current land use. Of course, it's forest, but this place has been was established in 1924, and so it is now celebrating the 100 years anniversary, this place. And that time it was a pasture, and it was a pasture because the whole of this region is characterized by the soil association of glacial soils, solonetses, all this kind of hydromorphic soils, with sometimes where you do have a little bit higher elevation on the surface, Chernozem or Feozem formation. This is a kind of very typical complex association of the area. So that is changing from one location to the other one. And that was because of this. If we just go 1 kilometer to the east, to the west, whatever direction, where the official border, where we leave the official area of the research unit, we arrive to a pasture, to a salt-affected pasture, which is a very traditional land use of the Földrajz National Park. There is a lot of folklore connected to that. That's why it has been selected or given the UNESCO National or Natural Heritage Site award. So that was a pasture. Now it is an afforested area where all of these forests, what we see around, it is artificially made. That was the part of the story where we were trying to reuse areas or give more value to areas which was not producing much as a pasture. But that time when it was established, the Hungarian forested area was quite low. It was under 10% of the entire territory, and we had to increase that, and that was the kind of goal. How can we do it on a plain area? So we have to have something what is not naturally connected to the forest, and when we look at this material, we will see that soon. So on the top we do have a beautiful dark color. Its Mansell value is 2.2/1 10 YR, which immediately meets the Czernik criteria. It's quite nice dark color, and this dark color is even more convincing when we look at the texture. The texture is clay loam, but it's a clay loam which is quite close to the clay, because the clay content is almost 38, 39, 37, whatever. So it's very close to the 40%, which would make it to going to the clay texture class. And we do know that as the clay content is increasing, then it is absorbing, fixing much more organic material, so the potential to increase the organic matter content for a clay loam area is quite high. Now it's about a little bit less than 3%. if you look at the texture, well, not the texture we already mentioned, but the structure is beautiful. It's really something, after spending a lot of time on farmlands where you see all the degraded structural elements, now it's a kind of paradise. However, and that's what I would like to highlight here, if you go down here between 15 and 30 centimeter, you see this very typical compacted, degraded structure, like exactly the same what you see in the plow pen often, or on any of this kind of very degraded plowing horizon. And why I'm really would like to highlight this is that we talk a lot about the regenerative agriculture, improving soil quality, and after 100 years of untouched potential to regenerate the structure, it has been done very well on the upper 15 centimeter, but here there was not much progress what we could make, and that's a message. How should we handle all this kind of structural degradation processes? It's not gonna improve by itself, or it will, but it takes much time, much longer time. Anyway, when we come further down, the color is getting lighter, so of course we are just approaching to the transitional horizon, to the B horizon, and here you already see a lot of reddish, brownish spots, the iron concretions. So the gleic properties, here there are only a few one here, but from 40 centimeter it is starting to dominate the entire horizon. So you see all this kind of gleic patterns, the reddish, brownish, plus the grayish. So it is evidently, you see all of these, a lot of iron concretions, small ones, but for sure it is what we call a gleic property here. So it starts from 35-40 centimeter. Here at the top, I have not mentioned it, but it's quite common in this area. The top horizon has no any calcium carbonate. And it has a lot of potential explanation why it does not have. But the interesting thing is that we often see a more clayey material on the top in this region, the southern Hajdúság and in others, which is always acid or neutral, slightly acidic, but it has no any calcium carbonate. And then just below that, often the texture is getting coarser and the calcium carbonate appears immediately. And it's probably, as you know, that if the material is transported by fresh water, and just try to imagine how does it work when you have a very, very light concentration on clays transported as a kind of floating material and surrounded with fresh water, so the leaching is 100%. You can wash away all the calcium carbonate, and what you sediment here, this kind of some long time floating and washed and leached material, it's often acidic. And the most typical ones, what you can see in the bodrokkers or in the taktaköz, that's the same origin, and the pH goes down to 4.5. So this is what you see here now. But here, these calcium carbonate concretions occurs immediately. And the interesting thing is that even the border is quite sharp. Which means that in any kind of areas like this, we always talk about sedimentation, but sedimentation, it means that we have to have a lot of sediments, and the sediments has to come from somewhere, so it means that we do have a lot of erosion in this area. And to get this high amount of relatively big calcium carbonate concretions, you need a much deeper the material above, when it is leached and the calcium carbonate is removed, and then it accumulates in the lower horizon. It means that we lost material from the top, which is quite interesting. Again, this is this ever-changing environment what we explained. And The features I like so much is again here. If we go a little bit further down, there is not much change in the gleic properties, but we do have nice grayish horizons. And every time when you see this gray 10 centimeter thick horizon, on both sides you see a very strong iron precipitation. And you know, it's a very typical evidence of fluvial material. When there is a higher clay content material is sedimented, and below that there is a coarser material, above that there is another coarser material, and when the whole profile gets saturated, of course it's saturated. There is no oxygen, anaerobic conditions, low RH value. And then when it starts drying, of course the coarser layers lose the water saturation, and the air, the porositic air, comes into the area again. But this finer texture layer keeps the water for a much longer time, so the reduction of the iron takes place for a longer time, and of course it starts to be transported to the top and to the down when it meets the coarser material and reprecipitates as an iron concretion, and that's why you see this beautiful reddish, gray, reddish kind of environment. And then you can go even further down, you see these repetitive patterns, the gray, the reddish, the grayish, the reddish, and the texture is basically more or less the same, but we still have 5–7% of a changing range in the clay particle share, basically, and that is what is explaining this kind of story. And also the other important thing is when you do have the big concretions, along the big concretions you always have a much higher porosity, which means it gives place to the reprecipitation of the iron. So yeah, we go down further here, and the next change, what is very evident, is starting from 120, when we do have this very grayish, again, it explains a lot. It's very gray, reductimorph color, so there are not that many oxidized iron in this place. And again, here this is how it looks like. The clay content is around 70%, so it's a big jump upwards, and the structure and everything is changing. And we see, even not in this condition, but even now, we see beautiful slicken slides, these shiny surfaces of the vertic horizon, because this is a vertic horizon where the clay content is increasing. Suddenly it is shrinking and swelling. It really creates all the important features, the slicken slides that is required by the vertic horizon. And it is now a changing environment which is above a little bit darker horizon. This darker horizon is a buried horizon, a buried surface horizon. And how can we explain this big jump of clay? It's quite easy, because there's the same story what I was explaining. Because if you are in a back swamp area and the current river bed is so far from here, it means that the farther you get from the river, the finer material accumulates or sedimented at the bottom of the back swamp. And here what we see, that we had a very calm environment, a marsh where it's not even flooded seriously. The water just slowly comes into the area and sediments a lot of clay and accumulates almost pure clay of 70% clay content. It's very unique in this sense. And that's the same story even behind, where the clay is 50%. It's a big difference, but even 50% clay is a very calm, marshy environment. So this is something what is a different story. And above that, it is this clay loam all the way. However, within the clay loam texture class, as I was explaining, there is a lot of variability, but that was a much more stable kind of one-way processing environment. So basically this is what we see from this profile, and there is one more information which is not really visible, but it is given by the lab data, and that is the salt. Because when we look at this profile, we see, of course, gleic properties. We do know and we can identify, especially because the top material is clay loam, for sure when it gets water, it gets saturated and the infiltration is very, very slow, so stagnation for sure happens. And as I was explaining, stagnation and glaciation in this area is basically always comes together, for sure. So we do have those. We do have the fluvic materials. We do have beautiful vertic down there at 120 centimeter. And what we have is the salt. And as I just look at the data sheet, the salt on the top, it's a little bit higher than the average of the plain area, but as I mentioned you here, it is a very specific soil associations of salt affected soils, glacial soils, so the salt is here everywhere. And in Hungary we use the 0.05 as a minimum threshold of salt content, and we believe that if the salt content goes above that, then the salt resistant, the salt sensitive plants may react that already. But here the salt on the top is about 0.06, 0.05, and around 1 meter it goes up to its double, to 0.1, and then it goes up to 0.3 from 150, 140 centimeter. So, and that's in this kind of environment is very, very high. So we do have a nice salt concentrations, which of course above the groundwater, so it's a groundwater origin salt accumulation. You can even see it from the salt profile, because on the top you have some, but it's hardly reach the threshold, and it goes down to 1 meter, and under 1 meter, this is the current groundwater table, the capillarity rise zone basically. So this is where the water starts going upwards, and the concentration is getting higher, water is evaporating, salt stays behind, and at the end that we do have a nice salt accumulation around 120, 130 centimeter. So this is basically the whole story of this profile. And if I just don't want to forget any of the features, if we would like to classify that based on what I was describing so far, based on the WRB 2022, we do have an oxygleic, really saying that we do have a lot of gleic property, but it's not reductimorph but oxymorphic colors, so a lot of grayish, not a lot of brownish, reddish color dominates the surface. We do have Chernik, as I mentioned, the color is very, very dark on the surface. So we do have an oxygleic Chernik glacial, which is loamic, or loamic lake, or something like that. Euterquic is the combination of the stagnic and the gleic properties together. Protocalcic, the highest calcium carbonate content is 13%. That is somewhere here around the concretions. Above that it is basically 0, and if you go down, it goes down to few like 5, 6, 7. But here in this groundwater dominated zone, there is some slight below 1%. It exists, but it's almost like nothing. So it's a protocalcic. And because we have identified the beautiful slicken slide, we do have a top-to-vertic horizon, bottom-raptic, showing that we do have a strong change in texture in a very sharp border. Body reductic, we see the grayish color down there, so the oxygleic on the top, the reductic is down, and body proto-solic. So in our Hungarian classification system, that 0.3 is quite high. Based on the international thresholds, it is just a proto-solic identifier. Anyway, so this is the World Soil of the Year 2025. I hope many of you will have the chance to visit the place, to visit the profile, visit the country and the culture, and enjoy the Hungarian wines. Goodbye.